Hello everyone, I'm Dan Anderson with Intel Corporation. Today I'm going to talk about Hyperledger Sawtooth performance metrics generated with InfluxDB and displayed with Grafana and how to set it up. The agenda, we'll first have an overview, then we'll talk about installing and setup for Grafana and InfluxDB, running Grafana, and troubleshooting, and then we'll have a live demo. Sawtooth optionally generates performance metrics, but they're not generated by default. You have to enable them. You could generate metrics from the validator component and the REST API. Additionally, system metrics can be generated by Telegraph to provide a more complete picture of your system. Metrics are stored in a time series database. This one happens to be InfluxDB. Grafana displays these metrics through a web browser, and it uses the InfluxDB as input. So here's an overall picture of what happens here. We have components on the left, the Sawtooth validator, the REST API, and information from the Linux kernel via Telegraph, and they're all written to the Influx database, the time series database. Then Grafana displays graphics, and it uses as its input what's in the Influx database. And finally, a human on the right could view the database as and metrics as displayed by Grafana. Metrics, as I said, are collected by the Sawtooth validator, REST API, and the system through Telegraph. Metrics collected by the Sawtooth REST API include the validator response time and batch submission rate. Then there's some further metrics collected by the Sawtooth validator. Next page. There's a whole slew of metrics here. Committed transactions, blocks published, chain head moved to fork, pending batches, batches rejected, transaction execution rate, transactions in process, transaction processing duration, valid, invalid, and internal error transaction response rates, message round trip times, and messages sent and received. System metrics include user and system CPU usage, disk I/O, I/O weight percentage, RAM usage, context switches, read and write I/O ops, the thread pool task runtime and task queue run times, and there's several graphs on thread pools, including workers in use, dispatcher queue size for the threads. Here's a sample of what are displayed, just some of the graphs that are displayed. Can't fit them all on one screen, but these are some of the more important ones, as you could see for Sawtooth. The top is blocks published, transaction rate. At the bottom, you see message stats. So like for each type of message, they have a different color there. So various kind of message types. You see how long they take, and you mouse over and see what kind of message is in each line there. Okay, so here's an overview of what you do to set it up. First, the prerequisites. You have to have Sawtooth already running and Docker CE installed. I will not cover that, I assume. It's already running and up and installed, and there's other docs and videos on how to do that. And then you install and configure the Influx database. Then install Grafana. Both of those are Docker containers. Then you configure Grafana, configure Sawtooth to generate statistics. Then we talk about installing and configuring Telegraph, which gathers system stats. So, first thing, Sawtooth and Docker CE. You have to have Hyperledger Sawtooth 1.1 running. You can also use 1.0. There's an extra step that I'll talk about later. And 1.2 is kind of that bleeding edge. I won't be talking about how to do that, but you need 1.1 running on Ubuntu 16, which is Xenio. And there's a link to a guide on how to install it on Ubuntu. It needs to be installed on Ubuntu. Installing on containers does not count. You have to directly install on Ubuntu. You also have to have Docker CE installed, and there's a link to instructions there. So to configure the Influx database, we create a container. So you first pull the container, Docker pull at the top line there. You make a directory, Influx data, and that's where the container data is stored, and that makes it persistent across reboots and starts and stops and recreations of those containers. So that makes sure those stats stay there. Then finally, you run the container. It listens to port 8086. That's what Sawtooth and Telegraph feed the metrics to. And then you see the mapping of the directories, and we see some environment variables that are set, including the administrator and data password and name. So for this demonstration, for the admin password, I use pwadmin, and for the data password, I use pwlrdata. So if you want to change it to another password, you just have to remember it to change it everywhere else, and that includes Telegraph, and the Sawtooth, and Grafana. So, and finally at the last line, I do a Docker PS, and that kind of verifies that that Influx container is actually running and up and running. Then we install a Grafana container. So this is the one that reads from the database and displays the metrics. So you first clone the Sawtooth repository, the entire Sawtooth repository. Then you change it to the subdirectory Docker in that repository, and you do a Docker build command, and that takes a while. You wait till it finishes building. It should end with the messages successfully built and successfully tagged. Then you run the container, and it listens to port 3000. So that's what you point your web browser to, port TCP port 3000, and then it displays all those nice stats once you configure it. And finally, Docker PS, that just verifies that the container is up and running. So once we have the container running, we could start our web browser and log in. So for this demo, I happen to have it on a VirtualBox instance called Tomolo. If you're running your web browser on the same system as Grafana, you could just use localhost :3000 to log in. So, and the password and the login password are both admin, and these have nothing to do with the Influx database or other passwords. So this is just for the Grafana web browser. And you could change it later if you want. If you want to change it, you click on the nice little Grafana icon in the corner, upper left corner there, and go to admin and profile and change password and change your passwords there. For demo purposes, I just leave it the same, or for testing purposes. But remember, port 3000 is exposed to the world. So if you have this on an external system, you probably want to change that password. So to start configuring, we need to tell Grafana where the database is. So you click on data sources you click on the icon on the corner there, then on data sources on the pull down menu. And this is what you get. You should get a data sources screen, and there should be one data source listed there called metrics. And you click on that. So then you get to a more interesting screen here, which you tell all the information about the data source. So let's see, under HTTP settings, under URL, you change the URL there. By default, it's InfluxDB, which doesn't mean anything unless you happen to have your host is called that. So you change it to the host name. It'd be localhost if it's running on the same system. Otherwise, if you're accessing Grafana remotely, you type in the host name, in my case, Tamalo, and leave everything else on that line the same. You want to go to port 8086. So that's, sorry, that's actually where the Influx database is running on Tamalo, port 8086. And you change the access from proxy to direct, unless you're going through a proxy, and usually you're not. Under Influx database details, we set the user to LR data and the password to PWLR data. And those were the values that we used when we created an Influx database container. If you decide to use another password, you better make sure you change every instance in this tutorial here and use that same password. It's just easier just to use the default password unless this is something for production or external use. Finally, after you're making all those settings, you test to see if it's good. So this tries to access the database, and if it's working, if it could access it over the network, it displays a green message: data source is working. Or first it says data source is updated, and data source is working. If it doesn't work, a red message appears with the reason it doesn't work, and usually it's a networking problem, firewall, proxy configuration, wrong host name, IP address, DNS problem, whatever. So you just need to get that working before you go further. So these are some additional steps needed for Sawtooth 1.0 only, the previous old release. For the current release, Sawtooth 1.1, you don't need to do that. Basically what you do is download the file sawtooth_performance.json, and that defines the Sawtooth dashboard that's displayed in Grafana. So once you download that either from the repository you created in a previous or prior step, or you just use wget and download it from the internet if you have internet access. So, and then you click on the Grafana icon, dashboards, import, upload JSON file. Navigate to the file, the directory and file where that you save that Sawtooth performance.json file, and click on import, and you should have that dashboard available to you. Again, this is not needed for the current release, Sawtooth 1.1. Sawtooth configuration. So we need to configure Sawtooth to generate metrics. By default, it does not do that. So we need to tell both the validator and the REST API to generate metrics. So you edit files etc sawtooth validator.toml and rest-api.toml. If those files don't exist, you just copy it from the example files that are in the same directory. For example, validator.toml.example to copy that to validator.toml. And you append these 4 lines to the end of the file. There's a little typo there. All those quote marks are just straight quote marks there. And if you decide to change your password, make sure you set whatever password you used in this screen. So these 4 lines need to be placed in both files, both validator.toml and rest-api.toml. Then you restart Sawtooth. So Sawtooth will reread those configurations and read those changes, so it knows about those new changes there. So if you're using system control, you just use system control, systemctl restart, and restart the component. Otherwise, if you started on command line, you could just use the start, kill it with pkill, then restart it on the command line. There's a typo there. Usually a pkill, sometimes you need a pkill -9 to make sure the process is actually stopped. That's a little typo I forgot there. And also, if you have special command line parameters, remember to also put them in when you restart the validator and REST API. So at this point, Sawtooth should now be generating stats, metrics, and sending it to InfluxDB. Telegraph reads information from the Linux kernel and also sends it to the InfluxDB. So this gives you a better picture of performance. So not only just Sawtooth metrics, but also system-wide metrics, so give you a nice picture of what's going on. So you need to install Telegraph. You download the Telegraph key with curl there, and you add it using the app key. Then you add the InfluxDB repository. Then you update your package listing, your repository, so it will read in what's in the InfluxDB repository. Then you install package Telegraph. And then, well, actually, next you have to configure Telegraph, next screen. Then you need to change etc Telegraph. No, you create etc Telegraph, telegraph.d, sawtooth.conf. So this is a new file. It has 5 lines as shown there. Again, if you change your password, you need to also change it here. This tells Telegraph how to access the Influx database, so it could send metrics to the database and have them recorded there. So after you created this file, sawtooth.conf, you need to restart Telegraph, system control restart Telegraph, so we'll read that newly created configuration file. So at this point, we should have metrics generated by not only Telegraph, but also about the system kernel. So we could try it out. You point your web browser to localhost 3000, or if you're accessing it on a remote web browser, the host name :3000, and you log in on password and user admin, unless you change the password, and you should remember it. Then you click on the nice little Grafana icon in the upper left corner, then dashboards, then home. Then in the home menu, you click on dashboard, and it should display the Sawtooth graphs. Usually it might be just blank because nothing's happening. So a good thing to do is to generate some workload so you could see something on the graph there. So I just, here's an example. I just start the intkey transaction processor and intkey workload, which automatically creates a workload at, in this case, at a rate of 1 transaction per second. You could bump it higher if you want. And that generates this workload until you stop the client there. And the -D5 means it just displays it once every 5 seconds, what it's doing. Then click on the refresh icon in the upper right-hand corner of your web browser, and you should see graphics coming along and output there. So, troubleshooting tips. Here's some tips to help troubleshoot in case you have any problems. You need to verify that both the Grafana and InfluxDB containers are up and running. Especially, well, you may have done a reboot or something. You need to restart it. So if you want to restart it, you would say docker start Sawtooth stats Grafana and docker start Sawtooth stats InfluxDB. So you verify they're running with docker ps. You verify that you could access on that host the Influx database and that it's listening. So here's a little curl command that would try to ping the port there. You specify localhost :8086/ping, and it should get you a no content message because, well, it's just empty message being sent back. But that at least confirms that the port is accessible. You can also verify that Grafana is accessible locally with the curl command by going to localhost :3000. What else can you do? You could also verify the configuration files, make sure they're all present and consistent, especially the open TSDB lines. Make sure the passwords all match. if you change the password. So for further information, I have a blog that's going to appear sometime soon on the hyperledger.org/blogs site. There's also the original Grafana docs on how to set up Grafana and Influx database for Sawtooth in the System Administrator's Guide following this link. And here's some links for Influx database, Telegraph, which is also produced by the Influx database people. And then there's information on the Docker Hub that you downloaded on Influx database. Finally, there's a link for Grafana, and then there's the Hyperledger Sawtooth website, which has lots of information, documentation, and FAQ, and especially if you look under contact, you could find links to the chat and mailing list to get some support help in case you have problems. So now we're going to have a demo. So I'm going to have to change my sharing here. Let's see here. Okay, so this is what I have going on here. We have a PS command. I just show you what I'm running right now. Sawtooth validator, dev mode, consensus engine, the REST API, intkey transaction processor, and the settings transaction processor. Finally, with Docker PS, it shows 2 containers running with Grafana and Influx database. Let's generate a workload. So I have a little shell script. You just type intkey workload -- rate 1 - D5, and that should generate a workload for you. And let's see, let's actually put that in the background. Let's have 2 processes creating this workload. So there's 2 clients generating 1 transaction per second each on Grafana. So let's go now to Grafana. So let's do a little refresh. Get me out of the way there. So you can see the block numbers changing from the first graph, committed transactions. Let's do another refresh here. Should have started earlier. You can see blocks published. It's going up recently here because I just started it. Pending batches, usually a lot of times it's 0 on light low workload. Let's see, one time it looks like it went up to 2. What else? We have transaction execution rate. That shows how many transactions it's executing, transactions in process, transaction duration at the 99th percentile, and it just looks like they take about looks like around 100 milliseconds. REST API validator response time takes only about 2.5 hundredths of a second, or 25 thousandths. Submission rate looks like it's submitting at a rate of 2 per second. That's because we have 2 clients submitting transactions. Response rate, and then we have invalid and internal error transactions. There's none yet there. this one is interesting, the round trip time at 95th percentile. And this is by type of transaction. So here we have, let's see, the red line is process request. That's the, takes the most there. Then we have consensus notify block valid message. Then we have a consensus notify block new message. So you can see how much each message type takes in hundredths of a second. Then we have message types per second send, and if you mouse over it, you can look at it. You can also expand these graphs. See a little tab on the lower right corner. You could just pull it here, so you could like zoom in on these graphs as you want more detail. Let's do another refresh up here. Get some more interesting information. Okay. Message received type. See all of these kinds of different messages. You can mouse over each kind there. Let's see. Host CPU. Usage, how busy it is. So for user, it's 22% busy, and for the system, only 3% busy. Disk. So as you can see, just recently, the disk got a little busy from writing all those transactions to the blockchain. And it kind of shows the rate of the writes there. There's no I/O waits yet. RAM shows you how much RAM it's using. Context switches, read and write I/O ops, and threads. Nothing real interesting there because it's really not being stressed right now. We have a lot of things about thread pools, how big the queue is, and the runtime and wait time and all that. So let's go back up here, refresh it again. So as you can see, you could change how much is displayed. So we could display it for the last 15 minutes. We could change to last 5 minutes and show that kind of a good way to zoom in on your stats here. Or you could go out, zoom out. Let's say instead of last 5 minutes, let's do last 1 hour. So there you go. So if you have any further questions, you could ask in the chat or mailing list, and look in the documentation on links there. So hope this is helpful. Thank you.